Hello everyone. Chapter 3 Matrices. Exercise 3.4. Using elementary transformations, find the inverse of each of the matrices if it exceeds the first sum 1, minus 1, 2, 3. So you can using elementary transformation, okay, and find the inverse. So first consider the equation A which is equal to I into A, and using elementary transformation, that is row operation or and column operation, any one, and finally we get I which is equal to B into A. So B is called the inverse of the matrix. Okay, so this is a procedure to find A inverse and using elementary transformation. So first of all, I consider the equation first. Let A equal to 1, minus 1, 2, 3. So consider in this format. So A which is equal to I into A, that is A matrix is 1, minus 1, 2, 3, which is equal to, we know that identity matrix in order to, so 1, 0, 0, 1 into A. Okay, so you can writing in this format, and you can using elementary transformation, you convert this format. The left hand side matrix is identity, and you should change any matrix in P. This is finally called an A inverse. So what is the identity matrix? 1, 0, 0, 1. Here already the 1 is there, so you can leave it. And you can see this here 2, but we convert to 0. So when we get 0, the multiply by 2 in row 1 and subtract with row 2. Okay, then you can apply the format. R2 implies R2 minus 2 R1. So using, there is no row 1, there is no change, 1 minus 1, and you can apply the format here, multiply, and we get R1 multiplied by minus 2. So minus 2 into 1, minus 2. Here minus 1 into minus 2, plus 2. And here also you can apply same procedure, minus 2, 0. So now okay, take the calculation sum. 1 minus 2, we get minus 1. Here you can using this format, 2 minus 2, we get 0, 3 plus 2, 5, which is equal to, the first row there is no change, 1, 0, 0 minus 2, 1 plus 0, 1 into A. So you can strike out this, because this is a rough work. Okay, you should say this, the identity matrix 1, 0 you get, and finally the diagonal should be changed to 1, and this value is changed to plus 1. So you can see the next step, second row divided by 5, second row divided by 5. So we get R2 implies 1 by 5 into R2, and do this, 1 minus 1, 0, 1 by 5 into 5, we get 1, which is equal to 1, 0, minus 2 by 5 and 1 by 5 into A. And finally we should convert to 0 in the first row second element. We can see this, when we get 0, the first row plus second row, we get this element is 0 and this element is not affected. You can adding these two rows. So you can do it, that is R1 implies R1 plus R2. Here we can apply the changes applied in row 1. So 1 plus 0, 1, minus 1 plus 1, 0. The second row there is no change, 0, 1. We can say this, the left hand side we get identity matrix in the order, and 1 minus 2 by 5, 1 minus 2 by 5, we get 3 by 5. 0 plus 1 by 5, 1 by 5, minus 2 by 5 and 1 by 5. So into A. Therefore, the finally we get in this manner, I equal to B into A in this format. So B is called an A inverse. Therefore, A inverse which is equal to 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. So the second problem, 2, 1, 1, 1. Let A equal to, you should take the matrix and consider in this format A equal to I into A. You can apply the value 2, 1, 1, 1, which is equal to identity matrix for order 2, 1, 0, 0, 1 into A. You can using elementary row transformation or column transformation, and we get A I equal to BA format. So identity matrix, the first element is 1 because we have 2, so you can eliminate 2 and we convert to 1. So you can using row 1 minus row 2 and get this value is 1. So we apply R1 implies R1 minus R2. So 2 minus 1, 1, 1 minus 1, 0. Second row no change, 1, 1, 1, which is equal to 1 minus 0, 1, 0 minus 1, minus 1, 0, 1 into A. And the identity matrix, we get this element, second row first element is 0 in the identity matrix. So we can subtract row 2 minus row 1 and get the write down the result in second row. So R2 implies R2 minus R1. Okay, here first row no change, 1, 0, and 1 minus 1, 0, 1 minus 0, 1. Here first row no change, 1 minus 1, 0 minus 1, minus 1, 1 minus of minus 1, we get 2 into A. We can say this. In this second step, we get the identity matrix in left hand side. So we get this format I equal to B into A. The B is called the inverse of the matrix. Therefore, we write down A inverse, which is equal to 1 minus 1 minus 1, 2. So this is your inverse of the given matrix. Thank you to all.